Hello, hello, hello! Welcome to another exciting geometry lesson. We're on Chapter 2, Section 2, which is called Conditional Statements. So our objective will be to identify, write, and analyze the truth value of conditional statements. We'll also write some conditional statements. And then we're going to learn to write the inverse, converse, and contrapositive of the conditional statements. So if you want to, go ahead and write the title down so you have it. And then the number 5, we'll try and incorporate that somehow at some time in this iPad geometry class. Alright, I'm going to go ahead and move on here. We're going to start talking about what a conditional statement is. Now the way I've got this page set up is I've got examples of conditional statements here. One of them says, if you get A's, then you will get a phone. Another one says, if you do your chores, then you can go bowling. And we've got to try and figure out what a conditional statement would be then. So what do these two statements have in common? Don't they have the if and the then? Well, yes, they do. I'm very glad you noticed that, TJ. So the if-then statements is just another name for conditional statements. Or I should say that probably backwards. Conditional statements is just if-then statements. Okay? Alright, let's move on here. And generally in our class we'd go ahead and take an example from one of the students here. So we'll say something like, if we score more points than Spring Hill, then we will win the game. So there's another example of an if-then statement. Alright, on this page there's a lot to this page, but it's mainly talking about the hypothesis and the conclusion. So the phrase following the if in the conditional is our hypothesis. The part that follows the then is our conclusion. And by the way, if you see this P implies Q, that just means that P is the hypothesis, which would imply Q, which would be our conclusion. So P implies Q just means that P would be the hypothesis, Q would be the conclusion then. Alright, so I think we're supposed to identify the hypothesis and the conclusion here. So it says, if points A, B, and C lie on a line L, then they are collinear. So the hypothesis is the part following the if. So I'm just going to drag this down here, and the part that's following the if would be points A, B, and C lie on a line L. Well, the part that follows the then is our conclusion. So what do we have that follows the word then? Would be they are collinear. And that's how we identify the hypothesis and the conclusion. I think we just have another example on this page. It says if the Patriots win enough games, then they will play in the playoffs. So the hypothesis again is the part that follows the if. So right there we would have the Patriots win enough games. That is also would be what the P would represent in our little mapping here. So P would imply, and then the Q would be our conclusion. And again, the conclusion is the part that follows the word then. So I'm going to drag this down here real quick. I'm going to go ahead and underline it so it starts with they will play in the playoffs. And this would be our Q. So P would imply Q. And it looks like we have one more example here. So if you get 100% on your test, then your teacher will give you an A. So the hypothesis is the part that follows the if, the conclusion the part that follows the then. So I'm going to underline you get 100% on your test. That's your P, which would imply your Q, which will be your teacher will give you an A. The regular class would do this. We're going to go ahead and move on. Pause if necessary, and rewind and look at it if you need to. So we're going to look at another example here. We're going to rewrite the conditional statement in an if-then form. So we're given a phrase and we're supposed to make it a conditional statement, basically. It says, all animals are warm-blooded. So to write that as an if-then statement, that means the same thing as this. We could write it a couple different ways, but we definitely need the if, and we definitely need the then. I'm going to say if an animal is warm-blooded, then the animal or it is a mammal. And that's how I can rewrite that statement in if-then form, which would be a conditional statement. Alright, we have another one down here that says, on Saturdays we don't have school. So I need to write that in if-then form. So I'm just going to write it nice and easy. If the day is Saturday, then there is no school. And it looks like we have one more statement down here which says all right angles are 90 degrees. So we need to write that again as an if-then statement. So I'm going to write if an angle is a right angle, then its measure is 90 degrees. So I took those statements and I just rewrote them in a conditional statement, an if-then form. Alright, let's move on. A regular class would do these problems at this time. We're going to go ahead. We're going to recap some vocabulary here. So conditional is just another name for an if-then statement. Hypothesis is the part that follows the if. Conclusion is the part that follows the then. And now we're going to talk about truth value. A conditional can have a true or false truth value, which means that it can be true or the statement could be false. So it says, what is the truth value of the conditional? If it is February, then there are only 28 days in the month. So we need to think, is there any counterexample to that statement? If there's one counterexample, then we'd say that is false. Well, most years, February has 28 days, but on leap year, there's 29 days in February. So with one false or counter example, we're going to have to say that would be false, although most years it would be true. Okay. Alright, determine if the conditional is true. If false, give a counter example. If two angles are acute, then they are congruent. Well, congruent angles have the same measure. If I had two acute angles, I could have a 60-degree angle and I could have another 30-degree angle. So these two would not be congruent, although they are both acute angles. So this would be my counter example, and that would have to be false. If an even number greater than 2 is prime, then 5 plus 4 equals 8. Well, back to that P implies Q. An even number greater than 2 is not prime. So if our P is false, then it doesn't matter what comes after it, because it doesn't really imply Q. So if this is false, it doesn't imply Q, so we're just going to say true. Anytime that our first hypothesis is false, then it really doesn't imply anything. So that would be true then. Alright, we're going to move ahead. Negation. Negation means to take the opposite meaning of a statement. So the opposite of the original statement would be the negation of that statement. Alright, we're just supposed to write the negation of each statement here. It says the ball is red. Well, most of the time writing negation just means to throw the word not in there. So we're going to write the ball is not red. And now I just took that statement A, which is ball is red, and I wrote it in the opposite meaning. So the ball is not red would be the negation of it. The cat is not black. To negate that, it's already got the word not, so I'm going to take that word out. It's going to be the cat is black. Alright? And then everybody's definitely not saying this statement, but I hate this class. Everybody really wants the negation of that statement, which is I love this class. It's opposite meaning. Alright? Or I do not hate this class would also work. Alright, the converse. We're going to go ahead and reveal these here. The converse is to switch the hypothesis and the conclusion in your conditional statement. So you would flip-flop the part that follows the if and the part that follows the then. The inverse is going to negate both the hypothesis and the conclusion. So we're going to change the meaning of both the hypothesis and the conclusion. And the contrapositive kind of does both of those things. So it switches and negates the hypothesis and the conclusion. And you might see if our conditional statement was that P implies Q, then the converse means that Q implies P. The inverse would mean not P implies not Q. So you might see those things. And the contrapositive would mean that not Q would imply not P. So notice how they switch hypothesis and conclusion and negate when necessary. I'm going to go ahead and end part 1 here. Part 2 will conclude here shortly.